So here we go. This is the second process. It's called diffusion. And diffusion is different to the advection process because the diffusion is sort of a two-way mechanism. It is a mixing mechanism. It has per se not a specific direction, okay, but what it does is illustrated in this example. Diffusion starts to work once you have a curvature in the distribution of a problem. Okay, so what's the curvature? Curvature is the slope of the slope. Okay, here's, for example, you can see an initial distribution of your concentration field in the x direction, and you can see lots of curvature. Lots of curvature. The slope changes all the time. It gets steeper and then it gets flatter and so on. Okay? So whenever you have something like this, then the mixing mechanism of diffusion starts to operate. And in the end, what diffusion wants to achieve is it wants to have a constant slope, a smooth curvature, or no more curvature, smooth transition. And this is what you can express by a diffusion equation. Yeah, that's how the diffusion term looks like in this equation. This is one example here. In one dimension, it has the second derivative. The second derivative is the curvature of a property. Second derivative is the derivative of the first derivative, the slope of the slope. Okay? And there is a coefficient, which is called the diffusion coefficient. So whenever you have curvature, then it's the diffusion operates, and how fast it will change the distribution depends on the magnitude of that coefficient, of this kappa that's in this equation. Okay? This is what we call diffusion. And I give you a few more examples. Let's have a look at some examples. One example, popular example, is just the spreading of a pollutant, okay, just injected. Here in this example, it's just some cloud, some pollutant injected into the air, and there's some advection happening here because there's the movement, upward moving, but at the same time there is mixing happening. Mixing leads to an increase in the width of this smoke plume. Okay. There are two different types of diffusion. One is slow, and it's based on molecular processes, and the other one is fast and it's based on called turbulent diffusion. And turbulent diffusion is actually created through instabilities. It's a very fast mechanism. Okay, and so what happens here is that initially, if you look at a cross section of, and you can again use the example of concentration field, you get a very strong curvature between the zero concentration, where there is no pollutant, and the 100% concentration. Okay, you get a very strong curvature, change in the curvature, essentially from no slope to a vertical slope here, okay, which is a 90-degree slope and so on. And what the diffusion does, it will actually smooth away the sharp corners. Okay, so you get these blue curves, light blue curves after a while. And this is in the example of the smoke plume, is just the distribution of how it looks like at higher levels. You know, you go away from the source at higher levels, and then you get smoother, smooth distribution. And this is what diffusion does. Okay, so why do I explain this all to you? Why do I explain this to you? And you will see on the next slides. Okay, it will all make sense.